In this presentation, we're just going to look at some hyperbolic functions, and really what we're going to do is look at a couple of the mathematical techniques and concepts that are useful when dealing with hyperbolic functions. So we have hyperbolic cosine, also known as cosh, and that is equal to e to the x plus e to the minus x all over 2. Sine, or hyperbolic sine, is also known as shine or sinh. I'm just going to go with shine. That's e to the x plus e to the minus x, minus, important difference between the two, over 2. And hyperbolic tan, and now we're going to really look at hyperbolic tan here, but it is simply cosh of x over sine of x, and that is equal to e to the x plus e to the minus x over e to the x minus e to the minus x. Not really particularly important in this particular presentation. The important thing here is that we might be actually asked to prove some sort of identity mathematical formula. So what I'm going to do is actually just to sort of emphasize a couple of things here in this presentation and just leave it at that. So for example, we might have hyperbolic cosine or hyperbolic sine the squaring terms. So we might be asked for something that involves cosh squared x or something like that. That is equal to all of this, e to the x minus plus e to the minus x over 2 squared. Something similar for shine. But what I'm going to do here is actually just sort of, first off, I'm going to re-express this. I'm going to put each of the terms over 2 separately. Okay. Shine would be something similar. Shine squared of x is e to the x over 2 minus e to the minus x over 2. But what I'm going to just specify is a couple of points. So suppose we have two terms here, a plus b. Okay, where a could be e to the x over 2 and b is e to the minus x over 2. A plus b squared, that is a squared plus 2ab plus b squared. Likewise, a minus b squared, this is relevant to sine squared of x, is a squared minus 2ab plus b squared. And finally, we might have the difference of squares, a squared minus b squared. That can be written as a minus b times a plus b. So all of these three identities are very useful when dealing with, or just to have them as a sort of the framework for dealing with further questions. Or just have them learned off, or remember, just be able to rely on them. For example, this would be A over here, this would be B, and that would be, you'd be using this one here. There's a couple more things I should say. So let's talk about powers, or particularly exponentials. So e to the x is the building block, as likewise we have e to the minus x. But suppose we are multiplying two of them, e to the x times e to the minus x. Okay, and what we do here, the rule here, the power rule here, or the rule of powers here, is that we add the e to the x and e to the minus x. So this is in the form a times b, or times a times c. What you would do there is a times b plus c. So what we have to do here is add them, e to the x minus x, and that is e to the 0, and that's just equal to 1. Anything to the power of 0 is 1. Okay, always. Okay. Another thing to remember is, yeah, e to the 0 is equal to 1. Oh yeah, e to the power of x squared is simply e to the 2x, okay, and e to the minus x squared is also minus 2x. So what we're doing here is any a to the power of b, all to the power of c. Essentially, you just multiply b times c. A, b times c. Okay? And that is quite useful because just going back here earlier on, I said you have to multiply a and b and e to the x plus e to the minus x. So, okay. One more thing, actually, just as when you're squaring terms that have fractions, remember to square the bottom bit as well. Okay, so suppose we have e to the x over 2 and we want to square that. Okay, that is e to the x squared. We square above and we square below. So above we would have e to the 2x and below we would have over 4. Essentially what I'm saying is when you're squaring a term like this, don't forget the bottom bit. Okay, it's over 4, not e to the 2x over 2. So just watch out for that as well. Let's quickly just see how we might square sine and cosine, or cosh and sine. So we'll just finish up on this. Cosh square root of x equals e to the x over 2 plus e to the minus x over 2 squared. Okay. Oops, let's put proper 2 in there. And so we're going to let this equal to a, and we're going to let that equal to b. So a plus b squared, okay, is a squared plus 2ab plus b squared. Okay, so a squared, e to the x over 2, square that, we get e to the 2x over 4, plus 2 times a times b, so plus 2 times e to the x over 2 times e to the minus x over 2. Okay, let's just separate out all the constant terms. So we have 2 divided by 2 divided by 2. So just like let's simplify all of them and just put the whole thing over 2. Okay, now we have e to the x times e to the minus x. And as we said earlier, that just simplifies to e to the 0, okay, and that simplifies to e to the 1, okay. And finally, e to the minus x, so b squared is e to the minus x over 2, so that is plus e to the minus 2x over 4, okay. And just to remember, so what we could do here is we have e to the 2x over 4 plus 1 over 2. We could just rewrite that as 2 over 4, just so that we have the same denominator the whole way through. Not absolutely necessary, but useful. Just as a sort of quick remark, you can easily determine sine squared of x, essentially just by changing that plus there to a minus. Sorry, this one here, that's sine squared of x is e to the 2x over 4 minus 2 over 4 plus e to the minus 2x over 4. Okay, that it would be sine squared of x is equal to that. Let's just go back to what we were dealing with earlier. Plus cosh of x, cosh squared of x. There we go. There we go. Now, I'm going to finish now on 2 more points. This is just relevant to something else. Derivative of cosh with respect to x is sine of x, and vice versa. Derivative of sine of x is equal to cosh of x. Okay, and the same thing works with the integrals. So if they're both the derivatives of each other and the integrals of each other. So cosh, the integral of cosh x dx is equal to sine x plus c. Likewise, the integral of sine x dx is equal to cosh x plus c. Just in case there's any questions that would relate to that. Alright, that's it.